Good afternoon, everyone. For today's review lesson, we're going to be talking about exponential relations. So like we've been doing the past few days, I'm going to run down a list of the main topics that we've covered and do a few examples of those so you have a feel for what kind of problems you have to be able to solve on your exam. Okay? And then you'll have time to work on your ISU and other things to get ready after that's done. So from our need to know list, okay, the first thing is the exponent laws, right? So when you're multiplying powers or dividing powers or doing power to a power, right, what do you do with the base and the exponent? And we'll review that in example 1. Okay. Also, zero and negative exponents, right? You should remember that anything to the power of 0 is 1, and you should remember what to do with the negative exponent, right? How you can change that into a fraction. Okay. The third thing is the graph. Okay, so remembering what the rough shape of the graph is the main thing. Right, so if your base is bigger than 1, okay, then it looks something like this. It's flat, right, and then it has a steep incline somewhere else. Okay, and if your base is a number less than 1 but bigger than 0, right, we don't allow negatives. Okay, the shape of the graph looks something like this. Okay, so again, you need to know the rough shape, right, and how you can tell them apart given the base. Okay. The next thing we did in that unit was to compare, right? If you have some information, how do I tell if it's a linear relationship, a quadratic relationship, or an exponential relationship, right? So we did a summary table, right? We know what the different graphs look like. Linear is a line, quadratic is a parabola, an exponential is one of those curves we just drew. Okay, we know how to find it from a table, right? If it's linear, then the first differences are all the same. If it's quadratic, then the second differences are all the same. And if it's exponential, then you have to do ratios. You have to divide the pairs of numbers instead of subtracting them. Okay. And also, we look at equations as well. Thing was a little bit of problem solving, right? To do an equation that involves, say, population growth or half-life on the exam, right? You'd be given that equation. It's just a matter of filling it in and being able to solve for what you need to solve for. Okay. So again, just for whoever's running this video, please feel free to pause it as needed to make sure students get down what they want to get down. Okay. And when you're ready, we'll start the first example. So for example 1, we're going to review the exponent laws. Okay, so we'll just do a few of these here. So for example, if I had 7 to the power 8 times 7 to the power of 4. Okay, so if I have the same base and I'm multiplying exponents, sorry, I'm multiplying my powers, then you have to add the exponents. So this will become 7 to the power of 12. Okay, if I'm doing division, let's say 7 to 8 divided by 7 to 4. Okay, when I'm dividing powers, then I'm going to subtract the exponents. So 8 take away 4 is 4, and that's 7 to the 4. If I'm doing power to a power, so let's say I have 7 to the 8, but then I raise it to the power 4, then you're going to multiply the exponents together. So I move 7 along, and 8 times 4 is 32. 7 to 7 is 7 to the power of 32. Okay. And the other two rules that we learned, right, those were the laws. If I say that 7 to the power 0, okay, you should automatically be able to say that's equal to 1, because anything to the power 0 is 1. And last but not least, if I have a negative exponent, so let's say 7 to the negative 8, the way I can convert that into a positive exponent is it becomes the fraction 1 over 7. So I have 1 over 7 and it's to the power of 8. That's done there. Okay. If I wanted to keep going and evaluate this, right, I could figure out what 7 to the power of 8 is. Okay, so this is equal to 1 over, and 7 to the power 8, 5,764,801. And no, I'm using a calculator. I didn't do that in my head. Okay. So for one last example of this, okay, let's do one that has multiple steps. So let's say I had 7, we'll use the same numbers here, 7 to the 8, 7 to the 4, okay, but that's divided by, let's say, 7 squared to the power of 5. So within my fraction, I can tidy up my numerator and denominator first. So the numerator, I'm multiplying the powers, so I'm going to add those exponents. So I would get 7 to the power of 12. On the bottom, I have power to a power, so I multiply. 2 times 5 is 10. Okay, and now, right, my fraction bar means divide. So if I divide 7 to the 12 by 7 to the 10, I am going to subtract the exponents. So I would get 7 squared. And if I want to evaluate that, 7 times 7 is 49. And that's my final answer. Okay. So that's kind of the level at which we'll be doing exponent laws. Okay. For example 2, and we did this a few times, right, here's a table of values. And I want to determine if this is linear, quadratic, or exponential. Okay. So it doesn't matter which one we try to go for first. Typically, we start with the differences, so we can start there. So if it was linear, then my first differences would all be the same. So let's check what those are. So first differences is basically how much is it going up by, right? From 11 to 8, okay, how much does that go up? That goes up 3, right? That's plus 3. To go from 11 to 16, I would be adding 5. To go from 16 to 23, that's 7 more. 23 to 34, that's 9 more. And 34 to 45 is 11 more. And you know what? Now that I look at it, no, it's not. I messed up my table of values. So I apologize. This should have been 32, and this one should have been 43. Okay, that's better. I apologize for that. Okay, so those are my first differences. Okay, and they're not all the same. Okay, so this is not linear because they're not the same. Okay, so now I go on to my second differences. Okay, and we see how much my new list is going up by. So to go from 2 to 5, that is up 2. To go from 5 to 7, this is up 2. Okay, to go from 7 to 9, that's also up 2. Okay, so my second differences are all the same. So this is quadratic. Okay, and realistically, if this was the exam, okay, or your final project, you could just stop there and say, oh, I found it, it's quadratic, because they're all the same. Okay, just to review how it works, okay, we'll talk about exponential as well. Okay, so for exponential, we're doing ratios. Okay, we're seeing how much you multiply by to get from one value to the next. Okay, so right, what times 8 equals 11? Well, it's definitely not obvious. So we take the second number, 11, and we divide it by 8 and see what we get. Okay, so 11 divided by 8 is 1.375. Okay, now I go to the next one. Okay, I have 16, and I divide that by 11. And I got 1.4545 repeating. Okay, I do the next one. I have 23, and I'm going to divide that by 16. 1.4375. Okay, so these numbers are not the same. In fact, they went up and then went back down. Okay, so it's not exponential. Okay, so those are the three tests that you can run from table value. Like first differences, second differences, and checking the ratios of your y values. Okay. Okay, for our last example, we're going to review how to fill in an equation for a word problem. So a population of rabbits doubles every 3 months. If there are 20 rabbits now, determine the number of rabbits in 2 years. Given this equation, I don't expect you to develop it, but we'll talk about where it comes from here. So the equation we had for population growth is if I have some population, right, that's equal to my initial population, okay, and then we're multiplying that by, in this case, it's doubling, so that's times 2. Okay, and my exponent is the length of time divided by the doubling period. Okay. So we'll start filling some things in here. So my initial population is 20. We have 20 rabbits. Okay. The 2 stays the way it is. Okay, I'm going to start with the doubling period. It says it doubles every 3 months. So I'm going to put a 3 there. It doubles in 3 months. Okay. Now for time, okay, it says it was 2 years. Okay, so just on the side here, right, I have 2 years. Okay, but my doubling period is in terms of months. So I don't want to put 2 in there because then I would have 2 different units. So I have to change that to months. Right, 2 years is 24 months. So I put a 24 in for T. Okay. When you're solving this, okay, first thing you should deal with is that exponent, right? Let's make that exponent into a whole number or decimal. So I have 24 divided by 3, and that's 8. Okay. So now, from BEDMAS, I have to do 2 to the power 8 next, and that is 256. And now I'm going to take that and multiply it by 20. So I have 5,120. Okay, so if you start with 20 rabbits, if the doubling panned out the way it was expected, then in 2 years you would have 5,120 rabbits. Okay, so that's the end of our review lesson. Thanks for listening. Whoever is covering the class will have those couple extra questions I usually give from the textbook. Okay, but of course you've got your ISU to work on, right? Your final project, and you have the practice exam if you need something to work on to help you prepare for the exam. Okay, and also don't forget, right? That final project is due tomorrow. Okay, so by the end of tomorrow, when you leave the school for the weekend, I have to have that project in. Okay. All right. So enjoy the rest of your day, and I will see you tomorrow.